source of this audiobook. Astrobiology is a wide-ranging subject dealing with the possibility of life beyond Earth from every conceivable angle. To start with, however, let's kick off with a much simpler question. Is there life on Earth? From our perspective on the surface of the planet, it's obvious there's life on Earth. From out in space, too, it's not that difficult to detect. The night side of the planet is lit up by city lights. There are thousands of small artificial satellites in orbit. The radio spectrum is buzzing with structured signals that have no natural explanation, and the atmosphere is laced with industrial pollutants. But all those things have existed for just a century or so, a tiny fraction of the Earth's lifetime, which is about 4.5 billion years. Nevertheless, life, at a less obvious level, has existed for a significant fraction of that time, perhaps as much as 4 billion years. Until just under a billion years ago, all of that life, and the vast majority of it even today, took the form of tiny single-celled organisms, the microbes that scientists are so fond of talking about. Over the course of time, increasingly complex forms gradually evolved and were added to the mix of life on Earth. This means the question of life on Earth is a matter of definition. To a scientist, life includes any kind of living thing, even if it can only be seen through a high-power microscope. By that definition, Earth has been home to life for almost 90% of its history. On the other hand, people brought up on a diet of sci-fi movies and tabloid stories about UFO encounters are more likely to equate life with a technologically savvy civilization, in which case that 90% figure drops all the way down to 0.000002%. If we're going to look for life on other Earth-like planets, what are the relative chances of finding it by those two definitions? We can make a rough estimate by picking random snapshots of the Earth at different points in its 4.5 billion year history. On that basis, the chance of finding life, by the ufologists' or sci-fi fans' definition, is so tiny as to be virtually zero. By the scientists' definition, on the other hand, the chances are pretty good. So let's look a bit more closely at that scientist's definition of life. The nature of life turns out to be surprisingly difficult to pin down, and precise definitions tend to vary between specialists working in different branches of science. As far as astrobiology is concerned, a good starting point is the working definition devised by NASA in the 1990s. Life is a self-sustaining chemical system capable of Darwinian evolution. That's refreshingly concise, but it packs a lot into a small number of words. The first part, self-sustaining chemical system, is clear enough, but the latter part, capable of Darwinian evolution, hides a lot of detail. It doesn't just mean that our self-sustaining chemical system has to be able to evolve or change its form over time. First, there's an implicit assumption that the change occurs over successive generations, each of which is born, grows, and dies. Then there's that word Darwinian, after Charles Darwin, the Victorian naturalist who did far more than suggest that living species evolve. He argued that they do this for a reason, to adapt to the changing circumstances of their environment, and that they do so by means of natural selection, or survival of the fittest. The beauty of this definition is that it encompasses everything from the single-celled organisms that emerged on Earth 4 billion years ago, and may possibly be hiding under Europa's ice sheets, via semi-civilized primates like ourselves, all the way up to super-advanced life forms we can hardly even imagine. Astrobiology, the subject of this audiobook, deals with the possibility of life beyond Earth, wherever it falls in that spectrum. As the astro prefix implies, it's essentially a sub-branch of astronomy, using the same sort of telescopes, space probes and theoretical techniques that astronomers apply to any other facet of outer space.